Sorry, hopefully my throat will cooperate. Every time I start talking, it seems to give out on me for some reason. But I've been with I'm with the CSIRO. Oh, thank you. Which one do I put next? Okay. Yeah, and so I just want to give a bit of a talk about how we're doing our data collection on board our research vessel Investigator, and then how that's in the mostly OpenRVDAS space, and how we're modifying the system to do that, and the technology. So that's the ship again, and yeah, so the CSIRO is one of Australia's national science agencies. We've got locations all around Australia. I'm based in the Hobart site with the Indigenous community, and part of my role includes actually going out on the Investigator for roughly 85 days per year and monitoring the data quality and the data collection and all the IT systems on board. So there's a bit of the rough statistics of the vessel. I operate around 300 days per year. We've got 60 people roughly on board at any given time, and that's 20 ship's crew, and then 6 to 10 CSIRO-based marine technicians or support staff. So we're a little bit unusual that we get a few more technicians than most vessels to operate all of the equipment that we have on board, and then up to 30 science on board. Okay. Maybe I figured out this way. Okay. So the vessel was commissioned about 10 years ago in 2014. This is the last 10 years of our vessel tracks. So we do operate mostly in the Australian EEZ. We do go outside of it occasionally, so you can see there. But and then we do operate one voyage per year to the ice edge, lots in the Southern Ocean, and voyages as well. So our Investigator Data Acquisition System, which we call RVIDAS, because there's already too many RVIDASs, so why not put an I in there for Investigator? This is the rough outline of it. So it's very similar to all the other vessels where you've got the instruments coming in. I go through our OpenRVDAS instance, and that feeds, that creates the raw files, a parse file, and we do go use a Timescale database. We have a Delta system, which is an in-house built file aggregation system, so it's really similar to the OpenVPN system. And we use that system to transmit to SSDs as we bring to shore. We've got a merger application that creates our minute average hourly files that we send to our Bureau of Meteorology, and then back to a real-time visualization system that we host on shore by FTP. We've just started implementing and testing an MQTT system to do a real-time transfer of the entire data set, all the underway data, near real time to shore using MQTT, and so far that's working really well, so that we can get a whole of real-time replica of all of our data on shore, and then we use Grafana for our visualizations. So I won't go into too much detail about this because we covered it pretty extensively earlier in the week, but this talk was created for an audience that wasn't that familiar with OpenRVDAS, but it's open source tool for collecting data on board research vessels, though it wouldn't necessarily be limited to that. And this is just the basics of how it works. It has readers, transforms, and writers, which the whole thing makes up a set of a logger. So just for anyone who wasn't here on Monday, that's roughly how it works. I won't go into too much detail also about the Jinja template, because we did cover it on Monday as well, but just briefly, it's just basically a template which makes really complicated and large configuration and repetitive configuration file a lot easier to find when you can do variable replacement. And it's a really powerful templating engine actually, so it's not just limited to this kind of use. You can use it to define any kind of repetitive file system you have. It's pretty easy to use. And yeah, so basically we were dealing with these 5,500 line configuration files in the beginning, And that, as you can imagine, was not fun to maintain, to modify, or to deal with. And we would get lots of copy and paste errors. So that's why we did this Jinja template. So now we don't really have to change anything. The only thing we have to change is in the voyage devices file, which is 36 lines, so still long, but normally it's just adding something new to that. A few lines, running it back through the Jinja template, and then we get our configuration file. Instead of that whole process would have been adding a few hundred lines to this file without our templating system. And this is just a kind of example of an actual, this is what you'd have to write to create a device. And now we've simplified it to just that. And the defaults are defaults for global defaults for the whole file that you can have at the top. So the second major thing that we did was we changed the core RVIDAS uses the Python parse library. If anyone's familiar with that, but we wanted a bit more flexibility and control over our device definitions. So we're using regular expressions. We're familiar with that. So that's an example of what the Python parse syntax looks like. And we've changed it to use regular expressions because the Python parse uses regular expressions underneath, but you have to define all of the regular expressions ahead of time. And we thought, why do that if we can just put it in the device definition instead, which makes it a lot easier, at least for us. It's not as easy if you're not familiar with regular expressions, but there are lots of handy online tools for using regular expressions and testing them. So that's how we're parsing our messages. So another thing that we added was data types to our configuration, because we wanted the ability to actually specify what the data type is, because otherwise every time regular expression parses it, thinks it's a string, and then it'll happily in the database it's a string, a number. So we did define data types within our configuration files. So a couple of other features we're adding and taking advantage of are transforms and cache data servers. So the cache data server is built into OpenRVDAS, and it stores a few hours of data in memory for quick access. And that is so you can use those things in calculations, things like that. There's a few built-in transforms already, TrueWin, I think Max WinGus, and we are doing a few others, which Alex, I apologize, I forgot about this as I was reviewing my slides. We are implementing a transform that will give you the best source of ship position, which is still under development, and I'm happy to talk about that later. And then things like calculating the buffer scale, and we have a math transform which lets you define basic lambda functions inside your configuration to do things like unit conversions, and it'll perform those automatically on the data. So MQTT, this is still really new to us, so this is a late addition, but it's like Lewis is saying, it is lightweight, publishes really well over low bandwidth, high latency connections, because it uses a message queues, and so it'll bundle up all the data, and when it can send it through, it won't be connections down. And so we're running the Mosquito broker on board the ship and sending all the data back, and not using it on shore for anything yet, just because it's relatively new, but that's the plan, is to just have that full replication system so we can use that more effectively on shore rather than, having summarized data only, or waiting till the voyage is over. Delta is very similar to anything else. The checksums, file aggregations, it copies the files to onboard servers, and then for redundancy, and then we bring those copies back to shore and use the system to also verify them. All other systems. We do use Grafana on board. It's great. I think everyone's heard a lot about Grafana all week, so I won't bore you with the details, but we definitely recommend it. We use it extensively. These are just a few dashboards we're using. So another thing we implemented into RVIDAS was a Timescale database connector. So it already had built-in ones for Postgres, a few other databases, and we were originally using we did change the Postgres timescale because we decided that we really wanted to have a SQL database rather than a not a SQL database. And Timescale has a lot of really great time series features that we're taking advantage of. This, I won't go into detail here, but yeah, it's fast, it works really well, so that's why we decided to use it. But the database connector in OpenRVDAS is, we deviate a little bit from the core RVIDAS convention, which is they have a narrow table format, which is storing all the data in a single table. And we wanted to keep our database similar to how we had it before, where each sensor has its own table and then the columns are fields within that sensor. So, and another thing we implemented within the database connector that wasn't existing in any other database connector is automatic table and column creation. So when you define a new device within your configuration, it automatically gets added to your database the first time it sends data through, rather than having to manually add that into our database, which is really handy because it doesn't fail until you remember. And this is just an example of what our database structure kind of looks like for one sensor that has two different messages coming out. So there are a lot of nulls in there, but Timescale and Postgres can handle that really well. So well, we still have a bit of work to do here, although not as much anymore. We are going to do a lot more UDP broadcast. We're taking advantage of that feature in OpenRVDAS that lets you rebroadcast different data, such as, we implement the ship's navigation best position. So it'll be one stream that'll tell you what sensor is producing information and what the position is. So you don't have to worry about listening to 5 different streams or 5 different ports or worrying about which one it is. It's just one stream. Then that merger function to create the averaged summary files, we're going to do that with Timescale real-time views, with export to SD and NetCF, because those are legacy file formats we're using. So we still have to do that. And then in the future, we do want to stack more Postgres extensions on top of our timescales, like PostGIS, to allow us to do more geographical indexing. So things like that. I got to the end, maybe with time to spare. So, but I'm happy to answer questions about any of this and look for ways to, collaborate with the community on all of this stuff, because I think it's really exciting. We're all in the similar space. Lots of opportunities for sharing.
Somebody knows how to leave time for questions. No, you've got plenty of time for questions, so please ask. So I guess I'll dig into it a little bit. So I'm interested a little bit more in digging into the Flux versus TimescaleDB sort of performance, clarity. Yeah, tell me a little bit more about what prompted you to go in that direction.
Yeah. So we have been using Influx maybe 4 years. And while it worked really well, we found some pain points of it not being a SQL database, basically. This would things like moving data, which, I mean, moving it in terms of when you move it, you want to delete what was on it.
You want those ACID transactions.
You want it to actually move rather than just copy. So things like that. And then, when we originally had started using Influx, Timescale wasn't really mature enough. And then we revisit our architecture, which so it does have all of the Postgres performance compression, everything with the hypertext stuff that kind of glossed over. So we decided that we think that's better. It will perform better than Influx long term.
And are the queries fairly elegant?
Yeah, well, it depends on what you're doing.
Yeah.
But because we're more familiar with the syntax, I guess, we find that easier and more elegant. I think Influx does have a lot of really great capabilities.
But it's also its own language as opposed to the more familiar SQL, I suppose.
Yeah. Yeah.
Okay. Additional questions? We do have a little bit more time.
Another question I'd pose for everyone is if there's some interest in maybe collaborating in the Grafana space somehow. I mean, I know all of our underlying technologies and database structures will be different, but I know we're all using Grafana. I've seen a lot of really cool Grafana dashboards and stuff that I'd like to see. And that's just something I'd like to know more about, or a pathway to sharing some of that information.
Even something like a channel that people would get into. And
yeah, or
see
like,
those things.
yeah, here's this really cool new widget that I just found out about that we're using in this way, or yeah, I've recognized a lot of similar plots and thought, oh, that's really cool. Like maybe I'll do our widget that way, or put that information.
Well, that could be a good outcome to come out of Polar Data Forum 5. Is there anything else? Otherwise, what we can do is we can head into the break. Again, just a reminder for poster presenters. We'll try and bring the posters out, set up the electronic to rotate, and please come and discuss and take a look at them. Okay, thank you.
Oh, actually, sorry, I did just want to ask one thing. Sorry, Tess.
Yeah.
But just just a comment on that last bit, Steph, that sounds great about the Grafana, and I definitely like different plugins and like what works and what hasn't. I would definitely love to follow up and chat more about that when you're back here.
Yeah, well, I know that.
Same time zone.
Yeah.
Yeah.
All right, thank you, everybody. Please go ahead.